Alright, so this is your key to your test review. So to start with the graphs, on number 41 here, the amplitude is 1. The period is going to be pi halves. And we have that negative there, which means there is a reflection. So we need to pay attention to that. My parent function for sine looks like this. I do not have any translations, left, right, up, or down. So this is my first point, which is at 0, 0. This point here is going to be at the end of the period, which is at pi halves. This point, which a lot of you seem to forget, is halfway in between right here. Then halfway in between would be up at 1, since the amplitude is 1, but this is negative, so it's a reflection, so it's down here at 1, and then right here, it's up here at 1. So then I just repeat. And some of you are leaving out these points that are on the axis or maybe on one of the midlines. So make sure that you have the max, the mins, and then all of the ones that would be either intercepts or be on the midline. So every single one of my intercepts is on an x value here. And then I just alternate up and down. Like so, and then we sketch this in and we try and make it curvy, should not be pointy, something like this. Arrows, because it keeps on going. Alright, number 42, our amplitude here doesn't technically have an amplitude, but I do have a vertical stretch of 2. The period would be 3 pi halves. And then my parent function for tangent looks something like this. Okay, I do not have any translations once again. So this point that's at 0, 0 is at 0, 0. And then this is at the end of the period, which would be at 3 pi halves. The asymptote is going to be halfway in between, which would be at 3 pi fourths. Then there is no reflection, so halfway in between the intercept and the asymptote, I do the vertical stretch, which is at 2. So halfway in between these two, I'm down here at -2. And then I just repeat. So this is like 1.5 spaces up here. And this is 1.5 this way, and I'm down here. So 1.5, and I have an asymptote. 1.5, 1.5, 1.5, 1.5. It looks like that. And then I sketch it in, trying to get the points of inflection in there correctly. Oops. Sort of missed that point, but just make it bigger. And then, there you go. All right, 43. Amplitude here. Well, once again, this is secant. Amplitude doesn't technically, doesn't technically exist, but I do have a vertical stretch of 3 halves. The period is going to be 3 pi fourths. This is secant, which is the reciprocal of cosine, so I'm going to draw in my cosine parent function like that so I know what's going on here. Because the points it's going to have in common, these 3 points it's going to have in common, and then here are where the asymptotes are going to be. That's how I get to figure that stuff out. So still no translations here, so for cosine, I start at 0, 1, except I have a stretch of 3 halves, so I'm really at 1.5. There is no reflection. This is a point that's on my secant graph. Then, so that's this point. Then I need this one, which is at the end of the period. 3 pi fourths is right here, like so. Halfway in between these two, I come down here. So halfway in between, I'm down here at 1.5. Then the asymptotes are halfway in between here. So this is a space and a half, so I go over like 3/4 of a space, like this, and come back this way. And then I repeat. So there's a maximum, well, it's not really a maximum, but it's as far as cosine is concerned. Here, I have 2 spaces here, then everything is very symmetric, so do a lot of counting to get your stuff in the right spots here. And then down below here, it goes halfway in between. All looks like this. And then we put in those asymptotes. Okay, and then I draw this in like so. Arrows on the ends because they keep going. Try and make them curvy. Like my daddy always said, do as I say, not as I do. There we go. Okay. Then I'm going to move on to cosecant. Cosecant, here again, there really is no amplitude, but I have a vertical stretch of 3. The period here is going to be pi. And I am going to sketch in my sine parent function, because for this one, here are my asymptotes, right? And then these are points that the graphs share. No translations anywhere, so I'm definitely going to start with an asymptote on 0. Then one at the end of the period, which is at pi. Then I have one in the middle of the period, which is at pi halves. Then halfway in between here, I'm going to go up to 3. Halfway in between here, I go down to -3. And then I just repeat the pattern. And draw in my graph. And there is cosecant. All right, so then I have cotangent, and this one does have translations going on with it. So let's look at what we have here. Amplitude, again, doesn't exist, but I have a vertical compression of 1/2. The period, there is no b, so period is pi. Phase shift, we go to the right, pi. Go up 3, so my midline is at y equals 3. So sketch in your midline. Those of you that are not doing that, that's where some of your issues are coming in. So there's my midline. And then my cotangent graph, even though it's one of the reciprocal ones, I just suggest going ahead and sketching cotangent because it makes things a little bit easier. Cotangent looks something like that. So I normally have an asymptote at 0. However, I'm supposed to go to the right pi. So when I do that, I have my asymptote right here. The period is pi, so this asymptote here is at pi units away. This point is halfway in between the two, but up here on my midline. And then halfway in between these two, I'm supposed to go up. Parent function says 1, the vertical compression says 1/2, and so I have this and this. So then every pi, I'm going to have an asymptote. which means something you should be able to recognize at this point from what we did today is that even if I hadn't shifted it over pi, like if I could take this part out, it's going to be the same graph because shifting it over pi, it looks the same. Okay, so get these in here repeated. Okay, draw in my graph. There you go. There is your cotangent. All right, so then we have cosine, and fraction bars are missing, but I think we can probably hopefully figure that out. So this one I really do have an amplitude for, and it is 5/2. The period here is going to be 3 pi. Phase shift, I'm going to the left 3 pi fourths. Vertical shift is down 1, so y equals -1. My parent function for cosine looks like that. And my midline is at -1, right there. So my midline's like my new x-axis. I have, for cosine, I usually start here at 0, 1. So I'll put my pencil on my new 0, but go to 0, 1. My amplitude, though, is 5/2, which is 2.5. So from my midline, I'm really going up 1, 2.5. But then I have a phase shift to the left 3 pi fourths. So that's 1, 2, 3 pi fourths. And I'm right there. So that's this point. The end of the period has the same y value. So this is my same y value, but it has to be 3 pi away. Right? Well, if I can get 3 pi on here because here's 1, 2, 3, 4 pi, so that's pi. And then 1, 2, 3, 4, that's 2 pi. 1, 2, 3, 4, that's 3 pi. There's the end of my period. So halfway in between those two is the minimum. And so if I go, so that's 3 pi, so it'd be 3 pi halves, which is 6 pi fourths. So I can go 1, 2, 3, 4, 5, 6. But then from here, from my midline, I go down 2.5. And there you go. So then halfway in between those two, and I have 1, 2, 3, 4, 5 lines. So I go 1, 2, 3, and I'm here. And then you can just double check. I got 2 blank ones, 2 blank ones on either side. I'm good. So 2 blank ones and an intercept, and 2 blank ones, which is a new intercept on like my new x-axis. Then I just continue over. I go have 2 blank ones, and then I'm back down here. 2 blank ones, and then except. Oh yeah, and then 2 blank ones, and I'm back down here. Okay, and then I just sketch it in, trying to make things curvy. And when you get at the end, you don't like make it go up. It's going to continue back down. This doesn't have end behavior like polynomials did. Okay, and there's your graph. All right, so let's look on the back. Once it decides to change. Okay, so here are your inverses. Remember, for cosine, okay, cosine inverse, we are restricted to the first and second quadrants. For sine inverse and tangent inverse, we are restricted to the first and fourth quadrants. So the only kind of answers you get to have for that stuff. So the cosine inverse of the square root of 2 over 2, it's like what angle gives me that cosine value, and that answer is pi fourths. Arctangent of the square root of 3, so what angle gives me a tangent value of negative square root of 3? Well, positive square root of 3 would be pi thirds, and then this is negative square root of 3, so that's a fourth quadrant angle, which is negative pi thirds. The arc sine of the sine. Okay, so this is the one we had those rules we could use. Now, in this particular case, for 49 and 50, we don't have to use those rules. We may not even be able to. But on 51 and 52, you're going to need to. So you have to decide, like, this pi fourths, does it live in the domain and range of what I'm trying to do? Yes, pi fourths is between negative pi halves and pi halves. So the arc sine of the sine of pi fourths is just pi fourths. I mean, you can find the value, like the sine of pi fourths is the square root of 2 over 2, and then the arc sine of the square root of 2 over 2 is pi fourths. I mean, it works that way too. For 50, this negative 3 pi fourths, well, that's in the third quadrant, and that doesn't work for arc cosine, but I can work from the inside out. The cosine of negative 3 pi fourths, since it's in the third quadrant, cosine is negative in the third quadrant, so that means that I'm going to substitute in for here, and what I'm really finding is the arc cosine of, and then when I take the cosine of negative 3 pi fourths, I get negative square root of 2 over 2. And then the arc cosine of negative square root of 2 over 2, remember cosine is restricted to first and second quadrants, that's a second quadrant angle, it's a second quadrant pi fourths angle, so that is a positive 3 pi fourths. Now, 51 and 52. I can't work from the inside out. I can't find these things. I don't know what the tangent inverse of 3 is, and neither do you. So this is where you have to decide, like, can this work? I can take the tangent inverse of anything between negative infinity and infinity, and I can take the tangent of anything between, anything. I can take the tangent of any angle. So this lives within that negative infinity to infinity, which means I can use the inverse rule, so the tangent of the tangent inverse of 3 is just 3. Cosine of the cosine inverse. Well, I can take the cosine inverse of anything between negative 1 and 1, and this is positive, so I'm good, and that's, less than 1. So that means that this here gives me 3/7, and it's that easy. For these down here, when they're mixed, you have to work from the inside out. So I want the sine inverse of the cosine of pi thirds. So that means I want the sine inverse of, well, the cosine of pi thirds is 1/2, and then the sine inverse of 1/2 is pi sixths. That's my answer. 54. I want the sine of, well, cosine inverse of the square root of 3 over 2 is pi sixths. So the sine of pi sixths is 1/2. Here I want the arctangent of the sine of 2 pi. So I want the arctangent of, well, the sine of 2 pi is the same as 0. The y value there is 0. So I want the arctangent of 0. So what angle gives me a tangent value of 0? The answer to that is 0. All right, 56. I want the cosine of, well, the tangent inverse of the square root of 3 is pi thirds, and then the cosine of pi thirds is 1/2. Let's look at 57. All right, so I want the sine of the arctangent of negative 24 over 7. That's not something you can calculate in your head. Like, you don't know what that is like we know the other ones. So here's where we have to draw a triangle. Okay, and so arctangent, if it's negative here, it's going to be in the fourth quadrant. Here's my theta. So I'm going to label my triangle. Tangent is opposite over adjacent, so this is 24 over 7. And this is negative. So this is the Pythagorean triple. If you don't know it, then you need to do Pythagorean theorem and try and do it pretty quickly. You get 25 here. So I want the sine of the arctangent of this. Well, this is theta. So I found theta. It's this. I don't know what the actual measure is, but it doesn't matter, because whatever it is, I can find the sine of it, because sine is opposite over hypotenuse. And so the sine of theta is equal to negative 24 over 25. So 58, I'm going to have to do the same kind of thing. Draw my triangle, okay, and this is positive, so it's going to be in the first quadrant. Here's my theta. Cosine is adjacent over hypotenuse, so this is 3 square root of 5 and 11 right here. So I need my y value. So 3 square root of 5 squared plus y squared equals 11 squared. So that means I have 45 plus y squared equals 121. So y squared equals 76. Y equals the square root of 76, which is 2 times the square root of 19. Okay, so this is 2 square root of 19. So tangent then, tangent of theta is opposite, which is 2 square root of 19, over adjacent, which is 3 square root of 5. Then I have to rationalize. So I'm going to multiply this by the square root of 5 over the square root of 5. And in the end, I get that the tangent of theta equals 2 times the square root of 95 over 15. That's my answer. Okay, it's a weird one because the 19 made it weird, but works. Okay, so as I said in my remind text yesterday, we haven't even done this yet. It's coming Thursday, so I had totally messed that up. So don't worry about these. Don't even try and get through them right now because I don't want you making things more confusing for yourself. And let's look at the page that I handed out today. If you didn't get this, the blank one is in Schoology, so you could try and work through this before I just work it for you. All right, so let's look at number 1. Now remember, on these you have some options, and you need to be using your little green sheet because you will get something. You will get one of those tomorrow on your test. So make sure that you're comfortable using it and you know what's going on there. But you can approach these a few different ways. Most of the time, maybe not all the time. So I want to find the cosine of x if I have the cotangent and the cosecant. Well, I know cotangent of x is equal to cosine over sine. All right, so I've got cotangent, I want cosine, so this I can make into sine. So the sine of x is equal to negative 1 over 5 square root of 2. So if I rationalize that, I get that the sine of x is equal to, and I'll do that by the square root of 2 over the square root of 2. So that'll give me negative square root of 2 over 10. Then I can substitute this in. I have the cotangent. It is negative 7. That's equal to the cosine, which I'm looking for, over the sine, which is negative square root of 2 over 10. Now listen very carefully if you're getting these things mixed up. If I wanted to simplify this one fraction, then I would take this part and multiply by the reciprocal here, because that's how you divide fractions. But I don't care to do that. That's not my goal. My goal is to get cosine by itself. So what I'm going to do then, cosine's being divided by this. So to get rid of it, I'm going to multiply both sides by that thing right there, which means I end up with negative square root of 2 over 10 times negative 7 over 1. That's equal to the cosine of x. So then when I multiply, this is going to give me cosine of x is equal to 7 square root of 2 over 10. All right, so on number 2, we'll want to find tangent if I have the secant and the sine. Well, I know that tangent of theta is equal to sine theta over cosine theta. Well, I have sine theta. This can give me cosine theta. That would be equal to negative 5 over 9. So tangent, that's what I'm looking for. So tangent of theta is equal to the sine, which is 2 square root of 14 over 9, over the cosine, which is negative 5/9. Now, since this is the fraction I want to actually simplify, I take 2 square root of 14 over 9 and multiply by this reciprocal, which is negative 9 over 5. And then the 9's cancel out, so that gives me 2 square root of 14 over 5, and that's negative. So tangent theta is equal to negative 2 square root of 14 over 5. All right, number 3. It says use the Pythagorean identities. Like, that is the only choice you have. Now, 3, there's a mistake. This one wasn't my fault, though, even though I totally messed up a lot of this stuff. But I'll own my mistakes. I didn't actually do this one. Secant is negative. Secant is the reciprocal of cosine. So secant can't be negative when cosine is positive. That doesn't make any sense. So we're going to change this to sine. Okay. So Secant is negative, that's my cosine is negative, sine is positive, which means this has to be in quadrant 2, and this matters. This matters for the end answer here. And I'm going to use my Pythagorean identities. So I'm looking for cotangent. I can use secant, the secant squared Pythagorean identity, and get tangent, and then from there I can get my cotangent. So I'm going to use the tangent squared theta plus 1 equals secant squared theta. So tangent squared alpha plus 1 equals secant squared, and my secant is this negative 5 squared of 6 over 12 squared. So I get tangent squared alpha plus 1. Now, squaring this is where some people are doing the same kind of, I'm seeing the same mistakes. You're taking care of the square root in the numerator pretty nicely, but forgetting to square the denominator, so be careful. Also, when I square the numerator, I can square it. That's going to be 5 squared times 6, so it's 25 times 6. I could go ahead and multiply that together, but I don't have to, and I'm not going to. Let me show you why. So I get negative 25 times 6, that's what it ends up being, over 12 squared is 144. I could also just leave that as 12 times 12. But right now, this might make it easier to reduce, because I can reduce the 6 and the 144. Okay, 6 goes into 14 twice with 2 left over, so then 6 goes into 24 4 times. So 6, this reduces down to give me 24 right here. So I end up with tangent squared alpha plus 1 equals, oh, and that's not negative anymore because I squared it, equals 25 over 24. So when I subtract that 1 from both sides, I'm basically subtracting 24 over 24, so that leaves me with tangent squared alpha equals 1 over 24. Well, I don't care about tangent squared, I want tangent. So tangent of alpha is equal to the square root of 1 over 24. Now, it's actually plus or minus the square root, but we are in the second quadrant. This is why this matters. In quadrant 2, tangent is negative, so this is negative right here. And then I need to clean this up. I can take the square root of 1, and it's 1, so I get negative 1 over. And then the square root of 24, when I simplify that, that's 2 square root of 6. When I simplify this, or rationalize this, this gives me negative square root of 6 over 12. So that's the tangent. I don't want the tangent. I want cotangent. So cotangent of alpha is the reciprocal of this. Now look at what happens when I show my work. I could take the reciprocal of this, and then I'm going to have to rationalize. Or I could take the reciprocal of this right here, and I didn't necessarily even need that, and that's just going to give me negative 2 square root of 6. If I did use this, do the reciprocal and rationalize, I'll get the same answer. I'm just going to have to do some more math in there. Excuse me. All right, so let's look at number 4. Again, my directions say use the Pythagorean identities, even if there's other ways to do it. And so I have the tangent of A equals 4, secant of A is less than 0, so tangent's positive, cosine is negative, so we are in quadrant 3. And I want to find the sine of A. So I can use the tangent and a Pythagorean identity to find the secant, and then secant will give me cosine, and I can get to sine. So it's going to take me a couple of steps here. So I'm going to use the same one I used over here, which is tangent squared. So 4 squared plus 1 equals secant squared A. So 4 squared is 16 plus 1 is going to give me 17 equals secant squared A. And so secant A is equal to the square root of 17, but remember it's plus or minus, but it's telling me right here secant is negative, so that is a negative square root of 17. Well, I need cosine, so I can use the other Pythagorean identity. So the cosine of A is equal to negative 1 over the square root of 17. Now, I could rationalize right here, but I don't have to, because this isn't my final answer. If it was my final answer, I'd have to fix it, but it's not. So I'm going to leave it like that, and I'm going to use the sine squared A plus cosine, which is negative 1 over the square root of 17 squared, equals 1. That means that sine squared A plus, when I square this, it's going to become positive. It's going to give me 1 over 17. That's equal to 1. And again, if you had rationalized, you'll end up with the exact same answer in the end. It's just going to be some different numbers. So I really want to think of this as 17 over 17. So this ends up giving me sine squared A equals 16 over 17. So the sine A is equal to, I'm going to take the square root. So the square root of 16 is 4 over the square root of 17 here. I'm in quadrant 3, so since I'm in quadrant 3, this is a negative, and then I have to rationalize, so the sine of A is equal to negative 4 square root of 17 over 17. There you go. Okay, so cofunctions. Are you going to have to do a cofunction on the test? Yes, but I'm not going to put anything crazy on here. Okay, you just have to understand some of the basic stuff. Be able to use your little green sheet, and you'll be fine. So let's look at this. It says find the secant of y minus pi halves if cosecant y is equal to negative 1.08. All right, so secant of y minus pi halves is not on my green sheet, so I have to manipulate it a little bit. Secant of negative pi halves minus y. Okay, so now I have secant of a negative angle, and so I look on my little reference sheet. Secant of negative theta equals secant of theta. So this is the same thing as secant of pi halves minus y. Well, and then on here, secant of pi halves minus y is equal to cosecant. So cosecant of y. And I know what cosecant of y is right here, so I can substitute this in and I can bring this down, and I get secant of y minus pi halves equals negative 1.08. There's my answer. So let's look at 6. Well, I have the tangent of pi halves minus beta equals 0.37. Well, this I do have on my green sheet. That is equal to cotangent of beta. So cotangent of beta equals 0.37. I want cotangent of negative beta. On the sheet it says cotangent of negative theta equals negative cotangent of theta. Right? So I have cotangent of beta, and I want cotangent of negative beta. So I need it to be negative, so negative cotangent of beta is equal to negative 0.37. So now I can substitute for this, and the cotangent of negative beta, which is what I'm looking for, is equal to negative 0.37. And there you go. Okay. Last two here. I'm going to simplify these expressions. So when I look at 23, okay, and I'm not going to put any crazy ones of these on there either, but you have to be able to look at it and think, okay, what makes the most sense here? Changing everything to reciprocals on 23 right now doesn't necessarily make the most sense because you have two terms and they have something in common, so we're going to factor that out. So cosecant squared A times cosine squared A minus 1. All right, so then I'm going to see what I can substitute at this point. This cosine squared A minus 1. Well, I have a Pythagorean identity, and that Pythagorean identity says that you have sine squared theta plus cosine squared theta equals 1, right? So if I have cosine squared minus 1, cosine squared minus 1, that's going to move this over here. That would give me a negative sine squared. Your other option is just to substitute, for one piece and it'll get the same thing, but I think it's a little better just to go ahead and figure out how it works over here. But pay attention and make sure you're not subtracting backwards. It's easy to mess that up. Oops. So we get, see, I just wrote the wrong thing. So I'm going to have cosecant squared A times, now this right here would get replaced with negative sine squared, because once I move the 1 over here, I'd have to move that over there. It's going to be negative sine squared A. Right? Well, cosecant and sine are reciprocals of each other. So cosecant squared times sine squared is 1, and this is negative, so I just have a negative 1 in the end. All right, 24. Well, again, I could do a whole bunch of reciprocal stuff here. I think that would probably be just a little too crazy at this point. But I have two binomials in the numerator, and they are a difference of squares. Okay, same rule applies. So I'm going to multiply, and this is going to give me cosecant squared theta minus cotangent squared theta all over sine theta. Well, we have something on our sheet, and I know we wrote some extra stuff, but the one that you're actually given on these is cotangent squared theta plus 1 equals cosecant squared theta. Because remember, you want to make sure that you're subtracting in the correct order when you do this stuff. I need cosecant minus cotangent. Well, cosecant squared, if I subtract cotangent squared over there, I'd just be left with 1, right, once I move that over there. So I can substitute 1 in for the numerator, get 1 over sine theta, and that is going to equal cosecant theta. And there you go. I will be here for tutorials in the morning, and I do have math time tomorrow. You can do well on this test as long as you're not trying to freak yourself out.